Number 53 has an interesting polar function. R is equal to sine inverse of theta. So when converting between rectangular and polar, we've got formulas like x is equal to r cosine theta, y is equal to r sine theta. We also have y divided by x is equal to tangent of theta. And then there's the old x squared plus y squared equals r squared. And that last equation will help us because we could solve for r. So r is the square root of x squared plus y squared. So that tells me that on the left side, I can put that square root of x squared plus y squared. But what about the right side? What about sine inverse? Well, you could take any one of the functions that has theta, and you could solve for the theta, and whatever the theta equals, substitute it into the function. So let's see. It looks like the simplest one is probably going to be the tangent. So if you take tangent inverse of both sides, the left side is going to have tangent inverse of y over x, and then that is what theta equals. So on the left side of the equation, the r gets replaced with the square root of x squared plus y squared. On the right side, there's sine inverse. And then replace the theta with this tangent inverse that we just found of y over x. And then personally, I would like to simplify it and not have inverse functions. So I would take sine of both sides. So it's the sine of x squared plus y squared inside the square root. And then I could take tangent of both sides. So now it's going to say tangent of sine of the square root of x squared plus y squared. And then that would equal y over x. And then to simplify, I would just multiply both sides by x. And there's the function. So in polar form, it's just this nice little r equals sine inverse of theta. In rectangular form, to get the same thing, you'd get to use all of this stuff. Okay, then does it have a tangent at the pole? So the pole means the origin. So let me just get some space here. And put the problem down again. So when it says the pole, that means the origin. That means r equals 0. So if you substitute that r is equal to 0, and then solve for theta, so take sine of both sides. So the left side is going to say sino, or sine of 0. And sine of 0 is equal to 0, so that means that the theta equals 0. So does it have a tangent line when theta equals 0? Well, tangent line refers to dy dx. So in other words, does dy dx exist when theta equals 0? And then dy dx means that we need to go back to what does x equal and what does y equal. So if we're going to do dy dx, then I need to know what dy is. In order for that, I need to know what y is. So y is equal to r sine theta at all times. And in this case, it means that y is going to be the r, which is sine inverse of theta, times sine of theta. And then we would need to do the same thing with x. So at all times, x is equal to r cosine of theta. So in this particular problem, replace the r, x equals sine inverse, and then times cosine. And then we need to find the derivatives of each one, which means we get to do the product rule. So the dy d theta will be the derivative of sine inverse is going to be 1 divided by the square root of 1 minus theta squared. So there's the derivative of sine inverse. And as you can see, if you have something like theta equals 1, it's going to be undefined. Luckily, we've got theta equals 0, so that would still be defined. All right, that was the beginning of the product rule. And then leave the sine function alone. And then it goes plus, leave the sine inverse function alone, and then take the derivative of sine, which is cosine. And then when you plug in theta equals 0, the first one will be, so if this is a 0, that means that it's just 1 minus, so that's just 1, and then sine of 0 plus sine inverse of 0, and then cosine of 0. So the dy d theta would be, so right here, I said sine of 0, but I wrote sine of theta. Okay, so sine of 0 is 0, sine inverse of 0 is 0, so all of this equals 0. Now do the same thing on the right side. So the derivative of the x function with respect to theta is going to be almost the same. The derivative of sine inverse will be 1 over the square root of 1 minus theta squared. And then leave the cosine function alone. And then plus, leave the sine inverse function alone. And then we would need the cosine of theta. And hopefully I could fit it. Cosine, oops, I need the derivative of cosine. So that would be negative sine of theta. And then plug in the 0. So dx d theta is going to be, so when you plug in a 0, you would get, first one would be a 1 again, and then cosine of 0, oops, I wrote theta again, cosine of 0, plus sine inverse of 0, and then negative sine of 0. And what does that equal? So dx d theta equals, so cosine of 0 is 1, so this is 1 times 1. Sine inverse of 0 is 0, sine of 0 is 0, so that's just 0. Okay, so then dy dx, the slope of the tangent line, equals, you take dy d theta divided by dx d theta, which means that the 0 goes on top and the 1 goes on bottom, and then that is defined, that means it equals 0. Let me go back to the question and see if I answered the whole thing. Does it have a tangent line at the pole? So the answer is yes. So if for some reason the 1 and the 0 would have been switched, we would have got undefined, and the answer would be no. But 1 divided by 0 is a valid answer, yes. Not only does it exist, but I found out that the slope is 0.